Okay, we're going to start working on something called quadratic equations. So we're going to be solving quadratic equations. Now, a quadratic equation is basically an equation that has a variable squared. Okay. So when the variable is squared, that makes it quadratic. Okay. So basically what we're looking at here, I'm going to want you to write a note on the side to undo, put undo in quotes, a squared number. Find the square root. Okay, if we're multiplying by a variable, we undo the multiplication with division or by multiplying reciprocals. If we have a number being added, we undo that by subtracting the number or using the negative. Okay, so here we're going to be eliminating the square by square rooting. Okay, so what we have here, and you should have room to do this on your paper. Actually, I take that back off. Well, yeah, let's do that. I think you can. What I'm going to do is I'm actually going to take the square root of each side of my equation. Let me back up. The reason we're going to do that is because I don't want to know what x squared equals. I want to know what x equals, right? So in order to figure out what x is, I need to undo this squared situation. To undo a squared number, find the square root. So I'm going to square root the x. Whatever I do to the left side, I have to do to the right side. The square root of x squared is x. The square root of 4 is 2. Now, something I want to show you off to the side for a second, just so you can see why this part works. Okay. I'm going to rewrite x squared as x times x, right? And then I'm going to break down the 4 for a second. The reason we know that the square root of 4 is 2 is because 2 times 2 equals 4, right? So 4 equals 2 times 2. The square root of 4 equals 2, right? So the square root of 4 equals 2. And if we look here, do you see how if I take my 2 times 2, square rooting it actually tells me what number times itself equals 4? Well, 2 times itself equals 4. So the square root would be that number, 2. Same thing goes for my x's here. What times itself equals x squared? Well, x times x does. Well, the minute I find this pair of numbers that multiply, square rooting tells me one of those is your answer. X equals 2. So that's why this all works. All of this work is not necessary. I just wanted you to see how and why x squared becomes x. The numbers, for the most part, everyone's done enough to be able to understand that. But these variables and the square rooting is a little bit of a new experience for some people. All right, number 4, a squared equals 9. So I want to find out what a equals. So I have this square here that's causing me trouble. But to undo a square, I take the square root. Whatever I do to the left, I have to do to the right. So to square root a squared, I think what times itself equals a squared, and that's a. a times itself equals a squared. Square root of 9, what times itself equals 9? 3. My answer to number 4 is a equals 3. Number 6. On number 6, I want you to change the problem on your paper. Make sure the problem on your paper says x squared equals, oh, that's horrible, sorry, equals 36. I want you to try this one by yourself. So hit pause and see if you can figure this one out on your own. Okay, so I need to make x squared become x. So I'm going to square root it, and square rooting undoes it and leaves me with just x. 36, I need to square root that because whatever I do to the left, I have to do to the right. Square root of 36 is 6. All right, starting in number 8, we have a new element involved here. Now I have a number or a coefficient in my situation here. We're going to continue solving these equations just like we would solve normal equations. Okay, if this was 9k equals 16, I divide each side by 9, right? Or multiply by 1/9 to eliminate. And then I'd be left with k equals whatever, right? That's how we start to work this problem. Okay, so the process has not changed. The rules are still the same on how to solve these. So I don't want this 9 here. I need to start getting this k by itself. So in order to eliminate the 9, it's being multiplied by k squared. So I'm going to divide it. Or if you like the reciprocal that we've been using throughout the school year, you would multiply by 1/9. Either way gets us the same result. For space purposes, I'm just going to go with this. My 9's cancel, and I have k squared equals 16/9. Now, this is a necessary step for your work. Do not skip this step. You've got to show me the algebra work that you're doing here. Okay. So now I have k squared equals 16/9. Don't worry, right? If I look at my fraction, I can't simplify that. There's nothing I can do, right? If you can simplify it, simplify. But I can't. So I'm not going to stress. I'm going to look at this and say, well, I have k squared here. So I can square root that and get k. Well, if I square root the left, I've got to square root the right. Now, from our review, you should know that I can take the square root of 16 and take the square root of 9. And that will get me my fraction that k equals. Square root of 16 is 4. Square root of 9 is 3. K equals 4/3. Okay. So again, if I can't simplify this fraction, I'm just going to go ahead and square root and see what happens. Now, if nothing is perfect, like if I don't have perfect squares inside, that's when you pull the calculator out and you start figuring out your answers. Okay, number 10. We have another equation here. Looks a little different, but everything is still, for the most part, the process is the same. Again, if you struggle when you see these squareds, just think about what would you do if that squared wasn't there? How would you solve this equation? You can go through the same exact process with what we have here. Nothing has changed. It's just that at the very end, we have a square to deal with. So I'm going to remind myself that I'm trying to eliminate I'm trying to get r squared by itself. So I'm going to add 3 to both sides. Because adding 3 to my minus 3 here, that becomes 0. Remember, if I add the opposite, I have a negative 3 plus positive 3 equals 0, right? So I get r squared equals 64. Thing is, I don't want r squared, I want r. So the only way to eliminate that square is to take the square root. Square root of r squared is r. Square root of 64 is 8. So again, the same equation solving process until we get to this part. But this part isn't even that difficult. That's one little tiny extra step that you're learning, attached to something you already know. Let's take a look at another one. Now I have multiplication again. 6 is being multiplied by p squared. To undo multiplication, we divide. I need p, not p squared. So to undo the square, I'm going to take the square root. If I square root the left, I have to square root the right. Now I definitely don't see perfect squares here. 402 is not perfect, 6 is not perfect. So what you do from there is we're going to divide. So we're going to say 402 divided by 6. And we get 67. Now, I didn't square root anything yet. I'm just simplifying this fraction because sometimes when you simplify the fraction, you get a perfect square. Now, in this case, I did not get a perfect square. So you have two options. If you have access to a calculator, you can calculate the square root. If you don't have access to a calculator, this can absolutely be your answer. If you don't have access to a calculator, how are you going to, unless you want to do the estimating, but for the most part, you won't have to worry about that. If you want to take a calculator and calculate the results, you would have, we would want to use approximately 8.2 if I rounded to the tenths place. So again, this is okay unless you're given access to a calculator. Okay, so our number 14 seems like it would be a little more complicated, but actually it's not at all. Remember, think about it without the square. What would you do first? How would you solve? This is just a two-step equation. That's all this is. Okay, that's this square that I have. That's something we handle at the very end. So this is nothing that you haven't done before for the first few steps. So I'm going to add the opposite first here. Now remember, if that square wasn't there, I would be still eliminating the number without the variable, the constant, right? We can make that 0. And I get 4x squared equals 36. Then I just continue to solve. Remember, imagine that square isn't there. What would you do? Well, you could multiply both sides by 1/4. You could divide by 4. Same thing. Those cancel to 1. Now at this point, 36 over 4 I can simplify to 9. And again, you want to simplify that if you can. Okay, if it's possible to simplify, do it. It'll save you some work. Because now my final step, if the square wasn't there, we'd be done. But I have a square, and to undo that, we square root. And I get x equals 3. Remember, each of these steps are steps that we've done so many times. This last one right here is the only new thing that you're seeing. That's it. Number 16. Again, we have a two-step type equation with my square. Think about what we would do to solve it if that square wasn't there. This 3 is my constant. I want to eliminate that first because 4b squared plus 0 is just 4b squared. So if I can make that 0, I can start finding b. 4b squared equals 100. Eliminate the 4 that's being multiplied. Remember, if it was 4b equals 100, I would get rid of this 4, right? So that's what we do. 4's eliminate, and I get b squared equals 25. I'm not done because I don't want b. I don't want b squared. I want b. The square root of b squared is b. Square root of 25 is 5. And that's it, you guys. It's as hard as it gets.